Okay, welcome everybody. This is another working group batch meeting. Today is August 29th, 2014. Today we have two topics in the agenda. The first one is by Kevin and Dave about multi-instance GPU and queue through device plane. So Dave, you can take it away.
Sure. All right. So hopefully you can see that. All right. So this is hopefully this will be a relatively quick topic just to keep us on schedule. So we just want to talk a little bit about resource abstractions for supporting this multi-instance GPU and queue and ways we could do that a little bit better with some minor extensions to queue that I think will give a better user experience. And just as sort of a review or a background for people, so this is a multi-instance GPU. Some of the high-end accelerators from NVIDIA and other vendors let you break a single device into multiple logical devices, partition it. And in particular, in the case of the NVIDIA, the MIG, they support two modes in Kubernetes. So one is this single mode, which is the top little design there. So you can take your GPU and slice it into different sizes. But you do that, you slice up the device uniformly, right? And so then what happens is what get exposed by the GPU operator is instead of having a single GPU, now your device, for example, if you picked row 3 where you split it into 7 of these 1G 5 gigabyte slices, you get 7 GPUs. But there's also a second mode, which is called mixed, where you can actually mix and match different kinds of MIG slices on the same device, right? And this is much more flexible. It gives you a better way of using the GPUs to support different sizes of inference workloads, for example. The thing that's unfortunate is when you do that, what the GPU operator actually exposes to Kubernetes as the available resource on the node is something like the following. So if I picked row 4 where I want a 4G 20 GB and 2 of the 1.5s and 1 of the 110, then my node has three different resources with these sort of odd names, where the name encodes both the compute piece, which is the 1G, and the memory, which is the 5 GB, right? And so that's what gets exposed. And if you want to do resource management for that, you have a couple of choices, but you basically have this explosion of different but interchangeable resources. And in particular, in the case of MIG, what we think is really what we want to do for quota management is to extract them all into a single, more interchangeable resource, like called accelerator memory, for example. And so then you could do management of your quotas for people saying, you have you're allowed to have two GPUs worth of slices. I don't care how you slice them up. And so you get 40 gigabytes or 80 gigabytes of accelerator memory, right? And so the thing we think would be useful for queue is to have this configurable abstraction function that lets us take a resource name and map it to another resource name and a quantity, and an option to either replace the old resource with a new resource in the workload, in the description of the workload of the resources required for the pod, or to augment it with a new one, depending on the use case. And so what I wanted to do show now is I've got a quick prototype of this that I did yesterday. And I opened a PR just so people could see it. It's not the PR I would actually submit, but the basic idea is I've implemented this mapping from one resource to another hardwired. Yep. Sorry, go ahead, Kevin.
Oh, I was raising my hand. I'll ask when you're done.
Okay, sure. All right. So the demo, so I've got a demo. I have a cluster queue set up where my quota is I've got some CPUs and I've got this accelerator memory type. And then I'm going to submit a pod where I ask for a MIG slice. All right. And if I actually do that, and then I look at the cluster queue again, we can see that it's admitted this workload and it's actually using 5 gigabytes of accelerator memory. But then if we describe the pod, the actual resource requests from the pods are unchanged. It's asking for one of these things. And so we basically, I've created a workload object with the abstracted resources. I'm not sure if we can see that in here actually, but right? Down here, it's asking for accelerator memory instead of that. All right, and so the prototype is relatively simple. It's basically just a small change to the adjust resources function in the workload package to do this expansion. The PR I've got right now really hard codes this in a way that's not what we want. And so I wanted to get some feedback from people on this is just how should this be configured? What you need is to do a general mapping, you need an old resource name, a new resource name, the quantity of the new resource, and whether you should replace or augment. And the two natural ways to configure this seem to be either do with a section to the queue controller config map, or we could define a custom resource like a queue resource abstraction or a queue resource abstraction function that you would then create instances of those resources. The queue controller could look at them and figure out how to do this mapping. Right. So that's basically what I wanted to give people a quick overview on, get feedback on, the idea, will this thing work, and how you would like it to be configured. So I think I'll stop sharing so I can see better, and then answer questions. I don't know. Al, do you want to go ahead and moderate people's questions?
Yeah, please, Kevin. Maybe don't. I can moderate, and please don't stop sharing because there might be
Okay.
questions about specific
Sure.
slides. Yeah, Kevin.
Yeah, my question is just, I'm not saying we would want to do this, but I'm just curious if there was changes to the device plugin itself, would this be necessary? Can you get everything you want out of this with changes there? Or do you still need changes in queue to accomplish this?
I don't know. I don't know. Olivier, do you
So
want to? Yeah, Olivier knows more.
maybe I can jump
Yeah.
here. So if it were the case that we could ask for, indeed, a GPU allocation in a pod spec in terms of memory and compute, just like we do for CPU and memory, and the mapping from these GPU and compute needs to, let's say, mix slices would happen, underneath, then potentially no, that could solve the problem, right? But that would require the plugins to have these. I mean, that would require the resource type, the accelerator resource, to be indeed exposed in terms of these uniform resources such as memory and compute, and possibly other things like NVLink. I don't know. um, uh, un until these are, distinct resources, and at the level of a pod spec, therefore at the level where Cube makes its quota calculations, then we need to have this form of aggregation, or a form of, again, like mapping different resource names to, a same scale, right? Or one or several scales.
Okay, yeah, I think that answers my question. I actually don't know a whole lot about Q and how it functions, so I can't ask more specific questions on that side, but I know at least from the device plugin side, we definitely, for the case of MIG, we wouldn't want to separate memory and compute for them because
Yeah.
they're somewhat inseparable.
Yeah.
But if you have a way that you want in Q to be able to say, well, I actually only care about the memory piece of it, then yeah, a level of indirection to reformat how those resources are being exposed into something that Q understands only in terms of memory probably makes sense.
I mean, just maybe to also react on that. So, when we think about, again, like classical CPUs and memory, we have two dimensions. We have CPU and we have memory, and you can request them separately. The reason, so because slices and GPU slice, or GPU in general, are also, compute and memory, and again, also we could get into memory bandwidth and other things, but let's say just compute and memory, conceptually, we could have two scales, right? We could have a quota in terms of GPU compute and a quota in terms of GPU memory. But what we know, what we observe at this point in time, at least this is the case with MIG, is that you cannot request half of the memory of the GPU and the entire compute, right? There's some wiggle room. There's, different slices are balanced a little bit differently, but overall, the amount of compute and the amount of memory are more or less proportional. And that means we can get away with having a single scale. We can get away with having a single quantity. We think memory is more meaningful to our users than SMs, let's say. But conceptually, what they've presented, this could, instead of mapping to accelerator memory, we could map these to accelerator cores with the exact same design, and again, that could be a choice.
Right. Yeah. I mean, you could also, as Olivia said, you could map this to fractional GPUs where you count in units that way, or fractional accelerators. Right. It's just a mapping from some concrete resource to a more abstract one that maybe you want to do quota management on, and maybe lets you lump together. I've got some NVIDIA GPUs, I've got some Intel GPUs, they both slice up, and I want to let a team use a certain amount of accelerators, and I'm a little bit less, I want them to be able to trade them back and forth, but I want to limit their total usage.
I think, yes, maybe, sorry, Aldo, last thing. To point also, we talk about accelerator memory because this is kind of our driving example, but you could, for instance, use the exact same system to say a slice on an H100 costs me twice as much quota as a slice on an A100, let's say, because I want to use this kind of scaling, not to talk so much about the again, the physical volume of resource I'm asking for, but something that's more of a reflection of the costs, right? And so I could map H100 things to more a larger number of units of quota than an A100 thing.
Yeah, you could skew them or score them in some way.
Yeah.
Martin?
Okay, makes sense.
Hey, I've got a question about how these things are exposed on the node side. So, do the nodes say that they have, I don't know, 4 MIG-1 G5 gigabytes resources, or you expose it as a total accelerator memory, or what?
Right. Yeah, so they get exposed on the nodes as the MIG things. This accelerator memory abstraction is within Q. It basically, it's just on the workload. We don't put it in the pod spec template. So it's an internal way of, as in this prototype of
Okay, so everything apart from Q operates on mix and fixed fraction. So if you divided the nodes into 4 pieces, then you cannot get 1/2. You need to have 2/4, right?
Yeah, until we make the division a dynamic process, right? And after the fact thing. But today with the GPU operator, it's a before the fact, yes.
So in Q, we just convert it into some other units that are aggregable, and in theory, we could convert it to straight dollars, let's say.
yes.
Hello?
So that goes also beyond the possible scenarios, because we may switch from the quota model to actually pricing model, and price machines also differently depending whether they are spots or on demands and so on. So instead of saying CPUs, we could go further and convert everything in dollars, and instead of resources, giving user a quota of, I don't know, $500, dinars, or whatever currency that there is.
Mm-hmm.
Right.
So that maybe possibly not only go to resources, like you had this mapping, like one resource name is translated to other resource name and quantity, but also expand it with a little bit of more context information so that we can, for example, use it for pricing machines, and then have it in much broader scope. Basically, like give the user a quota in dollars, and then whatever they ask is converted to dollars and assigned in some fashion. Just a wild idea. How
absolutely.
it could be a little bit broader.
So to be clear, so for instance, when I was talking about A100 and H100, or again, two different GPU vendors, maybe, what Dave prototype here is just looking at the resource name. What you just said, Marcin, is context. So indeed, if we want to distinguish something A100 to an H100, because the slice names, the resource names at this point in time are the same, we would have to go and look for attain, for instance, or some other piece of information, or the flavor in the case of Q that says if you're targeting H100 nodes and you want this resource, then this is the dollar cost, right? So
Yeah, sure.
so that's also something. I mean that if there's a, I mean, yeah, if we can design this larger thing, this is great.
Yeah. So that's the idea. Let's think a little bit broader. Maybe we cannot. Maybe there are some other things that would prevent us, but there is a potential for much broader feature that will solve both GPU slices and other things in a relatively consistent way.
Maybe I'll go with my question.
Mhm.
Just to confirm, the user knows exactly which kind of device they want, right? It's not like Q is going to decide which one it's going to give to the user. It's the user who chooses.
Right. The job being submitted still has some specific resource requests, and this is really a function that lets you take the resources the user requested and have a configurable way to map them to some other either additional or substituting resources that are what you really wanted, what the administrator wanted to manage their quota on. And that's why a piece of this is how you want to configure it. Like what I did in the code is I hardwired some strings. We don't want that. And so the question is, what's the right way to configure to let the person who deployed Q to figure this in a way that's customizable for their things, what resources they want in their cluster queues, how they want to map, the actual resources to these more abstract resources for quota purposes.
Yes. Okay.
Maybe,
Yeah. In principle, if we pair it with the idea of potentially converting to dollars, it's a very nice feature. Yeah, I guess we need to extend it because you might want to from this string NVIDIA/MG, we can split it into two numbers actually, right? Maybe memory and
Yep.
a number of cores. So that's one. But also, yeah, we might want to somehow mix in the node labels. Maybe not today. Maybe we don't have to implement node labels today, but we need to think if we were to add node labels, where would they fit in the configuration API? So something
Or
that we
resource flavors.
Sorry?
Or resource flavors. Make it combo of label, resource flavor, and then conversion to some currency.
Yes.
Yep.
Yes.
So, as was said, like we need an idea how to add additional context so that we could reuse it in more places and with basically like this same amount of code. It's just a little bit of extra API and that's it.
Right. Yeah. I mean, one thing that's nice about this feature is that you've already vectored everything through adjust resources. So most of the design is on how to configure it. The actual implementation is contained and relatively simple, right? It's mostly about the configuration and documentation of it.
Kevin, you want?
Yeah, this kind of goes aligned with resource flavors. So what I was understanding with MIG, at least and if you wanted dynamic slicing, you have 7 possible options on a node, and the resource flavors have a limit of 8. Is it like, do we, like, if we want, like, say we have MIG labels for resource flavor and anything else, we're gonna kind of hit that limit. So I was wondering, are we open to extending that?
That's in the cluster queue, you mean, right?
Resource flavors have, I think, a max limit on node labels of 8.
Okay. Yeah. Well, cluster queues also have, I think, limit on that as well.
I think it's 16 on there.
Okay.
But yeah, I was just like with resource flavors, because when I was thinking about like setting up a resource, like, because I think, you know, if we have a heterogeneous cluster, we might want to have labels of particular MIG slices, which has, you know, 7 different types, or maybe 6 or 7. But, you know, if there's anything else we want to add to it, we kind of hit that limit of the resource flavors. So I was kind of curious if there's any design limitation of why we went with 8 in Q.
In a lot of cases, we just try to be conservative and play safe. So if there is a use case for expanding, that seems fair. Yeah, it's not like a big string, you know, it's just a couple of a few kilobytes. So yeah, it should be fine.
Okay, thank you.
So I gather that either of you is gonna propose a cap.
Yeah, I can work on that. Do you think it should be try to go after some kind of configuration map or a custom resource, or more abstractly define the problem and then we iterate to get to that level of detail?
So options are, one global configuration. I mean, we have the configuration API already.
Mm-hmm.
That could be one option. Now that's global for the entire cluster.
Right.
Sounds like it could be okay for what you want, but if we are thinking about the dollar concept, then maybe it has to be in the cluster queue or in the
Mm-hmm.
resource flavor. Wait, no, in the resource flavor.
Probably a different API.
Yeah.
A new API that would land in. The problem with putting things in config is that this configuration needs to be very, very static, because changing in config requires queue restart.
Mm-hmm.
And not everyone is happy with that being happening often. On the other hand, dollars don't change that often, right? And it's probably not that important to be penny perfect. So from that perspective, it probably could go to config, but API would offer probably greater flexibility if we go with complex API. For very simple API that you convert this MIG name to some other resources that will probably not change in the next 5 years, its config seems to be reasonable.
I guess the answer is we'll leave it up to you to come up with a few alternatives, and then we can comment on those.
Okay. All right. That makes sense. I can do that. So I'll start working on that and hopefully get a initial thing done by sometime next week, and figure out how to stop sharing. And
Yeah. Wonderful. This is excellent idea. Yeah, I guess it kind of goes sideways from DRA.
mm-hmm.
But it's needed regardless, and yeah, it might be useful outside of devices as we discussed. Olivier?
Yeah. Just to double down on that, this is true. There's a maybe an intersection there, but like for instance, the array is about more dynamic configuration, and this notion of quota fungibility, you know, mapping to dollars or amount of accelerator memory and so on. This is valid even if there's no dynamic reconfiguration. This is a problem that exists irrespective of the hardware capability of itself being fungible.
Great. Okay, so if nobody else has anything else to add, I would like to give space for Andre. No, going
Yeah,
once.
sure. Hi, everyone.
Please.
I don't think we need much time. Maybe just quickly have a conversation. So I just want
Wait,
to, yeah,
do
go ahead.
you need to share your screen?
Not right now. Maybe we can start and then maybe I can share, because I don't have anything else to present, but I just want to talk about with you. Yeah, so just to give you an update, first of all, we finally merged the API changes to training operator and we started working with Yuki on the controller updates. So we probably will allocate some time to work on the job set as well. I know we have some caps we need to submit specifically for stateful, job sets and for like other parts like elastic job sets. So this probably will be done maybe in Q1 or once we kind of like have time for this as well. So I can share like our progress somewhere in the doc if anyone is interesting to follow up on this. So on the success on the startup policy, so I just want to discuss several things. I know this cap was proposed a while ago to make sure you can start multiple jobs within the order. And right now, I guess like maybe I can share my screen so we can all take a look at this cap. 1 second. Yeah, so we're talking about this cap, right? So I think the main API that is used here is this one, right? And like user can specify in order or any startup policy. And the main idea behind this API is to basically create the jobs how they've been listed, no matter what kind of condition they have. So as long as they have a ready condition, like all of the actually jobs all of the pods within the job have been started, you create a new job right within this within the order. So I know it's been discussing previously that you don't want to check the condition for the job before you will start a new one because you don't want to replicate the workflow engine like Argo workflow or Tecton pipeline, right? So I think my question is like we have some use cases specifically on pre-processing and post-processing when we need to have a specific condition of the job when we want to start a new one. For example, like, right, we want to do some pre-processing for the data set, for the model, or maybe do some initialization, or at the end, we want to export the model to some, blob storage. So I think I want to just talk about the motivation behind why we don't want to reduce, for example, target job condition to this API as the optional parameter, which basically allows us to trigger the jobs within the specific condition. Yeah, Kevin, go ahead.
Yeah, I feel like I should raise my hand since I did I did draft this kept in mind with actually supporting both the ready, like starting jobs in order based off if they were ready, and then I did actually have an implementation for based off succeeded. The main concern was that we didn't really want the job set to turn into a workflow engine, and that was like we kind of wanted to limit the startup policy to just be focused on like making sure that the driver, once the driver is ready, the workers can start, because that was the main use case we had in mind. I don't think there's any other jobs that people on this call right now, so I don't know like if it's worth revisiting that, but that was at least like it was explicitly called out, and it was asked to kind of drop that
Yeah. I
support
think
from job set.
yeah, we discussed. I mean, basically, the main use case is MPI, right? Because like you cannot run MPI run command if all of your workers are not, are not ready, right? And
Okay, for yeah, that was yeah, exactly that one. Also,
Mhm.
I think PyTorch masters and or
Yep.
parents and children and all that. That was the main motivation for why we wanted the startup policy.
Yep. Yeah, Aldo, go ahead.
There is another problem if we also look it from the queue perspective, because now quota management is unclear, right? We don't know at which point we're consuming how many resources, or should we admit, should we count the quota for all the resources that all the jobs are using? Probably not. Then yeah, that this prevents us from having a clear boundary for when the resources are gonna stop and start. I mean, it can be added, but it becomes more complicated, right? We need to communicate back which step we are, And then if there are no resources for the next job because they require different resources, then we have to requeue and things like that. So from the queue perspective, it becomes also harder. Yeah. So that brings us back to the support for workflow managers, which we never started. Maybe something along those lines could be started. It's just like what I'm trying to say is you have to think beyond job set.
Yeah, I think quota management is actually a good point, right? Because I think the question is like when you allocate some resources, like can it be, distributed across all of the steps of training, right? Because from a training perspective, right, like I don't think we really need to split quota management between pre-processing and post-processing because we're speaking about not really heavy computational tasks, right? Because like, for example, like if you really want to do, like feature engineering, right, you're using Spark, right? So probably you don't want to do this within the job, right? Or using some other like advanced, data processing techniques, right? So here, I think we're just speaking about some, um, small pre-processing, which doesn't require a lot of resources. But I agree with you that yes, the question how to integrate those with Q might be challenging. Yeah. Marcin, go ahead.
So yeah, like the Q related comment. So for example, Slurm has a dependency flag, so which tells basically don't start this job unless job named A, B, and C are started. So instead of having this policy inside of job set, we could have it outside of job set and kind of standardize in that way. So you can submit two job sets if you want. Each job set goes in full, but then there we have some annotation or whatever on top of it saying, hey, don't admit, don't start, don't do anything with this job unless something is completed or reach some other status. That would be like a very postman solution to like equivalent of workload engine, but it's relatively easy to implement and goes beyond job set for all possible APIs. However, the problem is that if you want to have this order, you need to put something extra on top, like Q or Go with full workload engine.
Yeah, but I mean, workflow engine is like much more complex than just ordering, right? Because here we're not speaking about the complex DAX, right? So we're just speaking about the order of the jobs, right?
Yes, but that's probably even worse if you're unable to specify multiple things or go in parallel. If you specify just I want to start this only if A, B, and C starts, then basically you can have full DAC equivalent, although scattered across multiple YAMLs, so not in a single place, but in many. But from the expressibility point of view, you get full DAC. If you go with direct name annotators, here you have not a DAC but a line, right? Basically.
Yeah. That's right. Exactly right. Yeah.
So
But
for
yeah. Go ahead.
sorry.
Go
So
ahead.
for Kubeflow, like what I was wondering is like for your training operator V2, like is there any reason why you couldn't use like a pipeline or an Argo workflow to kind of have the model workflow that you want? Or are you trying to like not have that dependency on Kubeflow
Yeah, we
training
we don't
operator?
want to have a complex dependency given that we just don't need like the full workflow orchestration, right? We just want to have a simple, like way people to do training, right? Or distribute training, right? Because and usually there is a kind of involved the initialization step and the finalizer step, right? So we're not talking about, some more advanced, things people want to do, or for example, hyperparameter optimization, right? Or maybe,
Are you kind of cut out a little bit?
Yeah. Go ahead. Okay.
You were cutting in and out.
Oh yeah, sorry. Yeah, I'm just asking that we don't want to have this dependency, as you said, right, on the Argo or on other, pipeline engine, and also we don't want to implement some other complex logic within training operator, right? Because it is only for initialization, like fetching your model, fetching your data set, and for exporter basically to put your model to some blob storage, right?
Yeah, I mean, my issue is I can envision a world
Mhm.
where somebody would say, like, if training is done and maybe
Yep.
for some reason there's a network problem with the model, I still like would want to maybe skip all those other steps and just repost the model, or like I've seen like success policy in the job API was kind of, there were some discussion about percentage of jobs that are successful. That means I'm overall good. But in this case, I can see like for a training operator, like maybe initialization of the model has to succeed, but posting, if
Yep.
there's a network problem, I don't want to restart my job if I'm coupling it with a workflow manager. And so that's kind of where it gets tricky, I
Yeah.
think.
I think the question is like back to the Marcin's point, like, so Marcin, from your perspective, do you think in that case, we should kind of introduce, multiple levels of job set? Basically, training operator should be responsible to orchestrate like multiple job set if we require such functionality.
I'm not exactly sure who should do that, but having like a simple order seems to be like the worst of two worlds. So
Yep.
you don't have full expressibility, but you still need to have workload like code in it. So it solves some of these cases, but as soon as they get a little bit more complex, you need to move it to the full-blown workload engine. You cannot run two things in parallel. These processing jobs could be a little bit larger. Like instead of just processing one set of files, you may want to process two set of files in parallel because each of them takes, I don't know, 1 hour. And maybe not that much resources, and you are limited by the, I don't know, disk throughput or whatever. And increasing the number of pods doesn't help here. So then you want to have that in parallel, and you cannot do it if you have a simple policy. So if you make it too simple, you still need code. You have complicated API, and you don't get enough expressiveness. On the other hand, if you go too far, then you will be doing full engine. And I'm not sure if it's the responsibility of job set to do everything. Like many things have landed on job set which don't offer full end-to-end functionality. Like there is a little bit of topology aware scheduling, right? But there is a lot of asterisk and fine print on it. Then you will add workload engine again with a set of fine print. So there will be a lot of features that work in very basic circumstances, but as soon as they need to go complex, they fail completely, and you need to have a different solution. And then
Absolutely. Yeah,
the API of JobSet gets a little bit cluttered. So maybe move it outside of JobSet altogether and provide like a simple way to express it while we're on other and keep the API, JobSet API, as focused as possible.
Yeah, that's right. I mean, we don't want to put a lot of complexity on the job set API, right? We just want to, understand how, from our perspective, the API should look like if we want to, offer something like this, right? When, we have like, distribute training job, you have your initialization job, and you have your, finalizer job, right? Which basically export a model, right? So because originally we're thinking about, hey, if we can, define the line within multiple jobs using the job set, the API will look very simple because we can still use the training runtime, which basically have a multiple jobs, and the jobs will be executed within the order, right? But the problem is because, I guess, like as we discussed, right, because it is not basically the role of job set. In that case, we need to build something different on our side, right, on training operator side, to, you know, have this part of the workflow engine inside training operator, right? So the one idea could be, you know, splitting this between the different jobs, right? And the job set after the initializer job is complete, right? But in that case, API could be really tricky, right? For the user actually, right? For creating those runtimes. Yeah. So any like suggestions from your perspective? Do you think like this workflow engine could be you know, delegated to, you know, our training operator, and we should design API in a way to give user ability to specify those initializers and finalizers?
My one suggestion would be that if you don't really need like the replicated job, I probably would try to put the initializer into just a single index job. Anyway,
Yep.
like I don't really know if there's a point of having like the job set controller kind of create this. So
Yep.
it might be more performant to just directly call the Q API to create the job.
Yes. I think the question is like, in terms of the API, it should be under the same template, or, you know, like we should check the name, for example, and create the index jobs, right, based on the name. Yeah, but I think like, I think the question is like, what is the exactly API will look like from the platform engineer perspective, who will create those runtimes, right? Yeah, I think this.
Are you saying that in most models or in most scenarios there will be those 3 steps? And if so, can the API be more explicit and be like, here goes your step 1, here goes your step 2, and that's your step 3, and each of them is tailored for the specific need, as opposed to just replicated jobs, which is what I see right
Yeah,
now.
of course we can define, for example, like, you know, initializer, trainer, and you know, finalizer inside the training runtime, right? And then we can define different templates on every step, right? And this also could be an option for us if we want to, you know, just change the API a little bit, because right now I have like the whole job set under this template, basically, right? Which allows us to, you know, like configure the job set for API, for Torch, right, for any other distribution, you know, framework. Yuki, what do you think about it? Like, should we try to split this API between multiple steps, or what is your perspective on this?
Yeah, actually, as we discussed before, so we are thinking whether we should have a dedicated initializer or finalizer index job template separate from job set template spec. But so I think API looks like more complex. So maybe so we have reserved name for initializer and finalizer, like kubeflow.org/initializer, or something like kubeflow specific name, and we can create initializer or finalizer for the reserved name template.
Yeah, this is like another idea, right? We were thinking about, you know, keep this API as it is, right? And, you know, reserve 2 names, because basically replicated jobs has job spec within it, right? So, you know, we can just take this as the index job, right? And basically create this as a separate job before we start a node training, right? When you do API or Torch training, right? That's doesn't require for us to have another, you know, like API just for initializer, right, or for finalizer. Yeah, I think the purpose of this call, I think, again, we can definitely think about API, but do we have any other use cases when you think the startup policy could be, you know, extended? Or again, back to the point about capacity planning, and you don't want to replicate the workflow engine, you think it is not the right API for it. like what do you think from the job set perspective?
I can give my perspective as skill developer.
Okay.
Yeah, I don't think job set is the right place to do this. But yeah, I'm not an owner for job set.
Mhm.
So Kevin and Abdullah might have a stronger say or a more valuable
Yeah,
opinion on this. But yeah, I don't think this is the right place.
I would. I mean, I would try to get Abdullah's thoughts on it. And I guess we can try to post in the chat and see. I know that. I mean, he was the one that blocked the initial part of the startup policy for Succeeded, and for the reason we have already talked about. So we can. I mean, I don't think there's any like we. It depends on the policy. I mean, we did build it as an enum to make it flexible for other options, but I don't know if like based off Succeeded or option is really what we want to go through with startup policy. But like, we're not saying startup policy is only locked down to support this one, but we would have to have a good use case brought up that to kind of design the API.
Yeah, it would be nice to understand, like, from HPC side of things, do you have any use cases there, right? When they need to have, like basically a sequence of the jobs to be succeeded, right? And manage this as the whole, in the single capacity, right? To allocate like the resources for the whole of the sequence of the jobs, right? So this I don't know like about the other use cases, right?
Yeah, I mean, I think there's a lot of use cases coupled with workflow engines. And that's kind of where that's kind of the capacity management. Because yeah, I've seen a lot of people use HPC with workflow engines outside of those Slurm dependencies, and like there's a lot of expressiveness you'll need for that. And as I think we've talked about in Q about supporting workflows, or at least Aldo and others have talked about it, there's a lot there. And there's the simple way of supporting it is each step in your DAG can just be queued to queue or whatever, and then continue. But there's obviously some people want to queue the workflow entirely and kind of reserve all the steps ahead of time. And there's a lot of policies that come into play. Sorry, tangent, not related to your question at the moment, but
yeah, it makes sense. So the next step, Kevin, do you want me to start a thread, or you can start a thread with Abdullah?
I'll have you start a thread, please, and then we can kind of see. Yeah, Abdullah would probably have final say on that one.
Okay. Yeah, let me just use the Bachelor group channel, then we can maybe have a follow-up there. All right.
Or GitHub. I guess a GitHub issue is better.
Oh, okay. Yeah, maybe GitHub issue also. It sounds good to me.
Yep. Okay. All right. I guess that puts us on time. So thank you all for coming. We'll see you in 2 weeks for the other time zone meeting.
Thank you.
All right. Thank you all. Bye.